Welcome back to Chem 330, Week 2 discussion on carbon compounds, and we've already finished discussing alkanes and alkenes, how to write isomers, how to name them. So now the last one on the list is alkynes. Alkynes. Similar to how alkanes had a general formulae of CnH2n plus 2. Alkenes had a general formulae of CnH2n. Alkynes have a general formulae of CnH2n minus 2. All right. So as with what we have done, to figure out if the compound contains a triple bond, these only have single bonds. These have both single and double bonds. These have single and triple bonds. All right. So to go, say I give you a compound, to figure out how many hydrogens would there be in a compound that's containing a triple bond would be, let's say I give C5, Let me get a different pen. C5, all you have to do, in all these cases, we do know that N represents the number of carbon atoms, right? Very good. So what that means is C5, 5 times 2 is 10, minus 2 is 8. So C5H8 is your formulae for this particular compound, right? So this is an alkyne, right? It's the general category of alkyne. We would learn how to name these in the next couple of videos. So now let's say, just like how we did for alkenes, how do I know? Well, this confirms, that our compound contains a triple bond. But again, the question is, how do I know how many triple bonds do I have? So to do that, again, the compound that we're working with is your given compound. And then the compound that we will find to work with would be our parent. How do we find the parent? Well, you guessed it right. You always go for the alkane general formulae as your parent, right? So if you have 5 carbons, that means your parent is C5H12. So that's your parent right there, right? Now let's come back and do our math. So to find how many triple bonds there is, just take your C5H12, right, minus C5H8, right? So that'll be 4 by 2 equals 2, right? All right. What this really means is that, you don't have 2 double bonds, When we talk about triple bonds, remember this is what this 2 is referring to, This is only for alkynes, So this is your sigma, you have a pi, and you have a pi, So what this tells you is, only if you get 4, you have 2 sets of it, If you just get 2 for an alkyne, you only have 1 set of this. That means it contains 2 pi bonds, right? As I said, even with alkenes, this number tells you how many pi bond there is, If you see it 2, that means you get 1 set. Say you get 4, that means you get 2 sets of it, because we now have 2 pi bonds on this and 2 pi bonds on this. So that's what it's referring to, So this is how you find how many triple bonds. So there is only 1 triple bond in this compound. There may be 2 double bonds, but there's only 1 triple bond. Let's go ahead and learn how to name these things. All right, so we have established this is our compound, and we have 1 triple bond. right? All right, so let's write 5 carbons. All right, and we do know our triple bond exists in this compound. Now, just like we did for our alkene, you can put your triple bond here, or you can go, because this is at least for the straight chain, okay? You have to move the triple bond around until you run out of options, okay? Until you run out of options. So this is the second one. Now, if I put it here, it'll be same as this. And if I put it here, that'll be same as that. And that's pretty much it for the straight chain. We're already done with the first set. So it'll be 1 and 2. All right, now let's go get our blue again. Let's cut the chain down by 1. Now, just like how we did for our straight chain, for our alkenes, now we only have 4 carbons, right? And we do know we can't put our we cannot put our extra carbon on the terminals, but the triple bond, they can go anywhere they want. Okay, so I am going to get my black again. It can go here, okay, and then you cannot put the extra carbon here. Why? Because this carbon now will have, let me actually do that. This carbon now has 5 carbons, okay, 5 bonds, sorry. And that's not acceptable, so this is not possible. Whereas something else is possible, which is, okay, I can still put the triple bond here, but instead of putting the carbon here, I can put it over here. Okay, now we do know we can't put them on the ends. Does that make sense? Okay, so this would be our third isomer. And you already guessed it. I think we can go for one more before we run out of options for the 4th chain. So let's go get our black. Okay, so 1, 2, 3, 4. Now we move the triple bond over here, right? And then now, what's the problem? Why can't we cannot put them here, right? Cannot put them here. We can only put them in the middle, that one extra carbon. But what problem are we running to? Do we run into any problem at all, if at all any? If I put it here, this carbon will have 5 bonds, right? That's not possible, right? And say I put it on the other side, that's also not possible, right? So let me get my pen. Right, so C, 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 C. Say, I mean, just like earlier, I put the triple bond here, okay? And I can't put it on the end, and I can say, oh, I want to put it here. Let's see what happens. Well, if you have a problem on the other side, the same problem is going to appear on this side as well, right? Because this carbon now has 5 bonds right here. Just like I said on this one, this carbon now has 5 bonds, okay? That's not accepted. So is this one. This has 5 bonds. So this is also not possible. If it's not possible with 3, there's no way you can even go down to 2. Alright, so C5H8 only has 3 possible isomers. Let's go fill it with hydrogens. Alright, so it'll be CH3, CH2, CH2, CH, CH3, CH2. I think it's already full, so it'll be CH3. Okay, and the same here, CH3, CH, CH3, CH. And it's always, as I said, it's a good practice to come back and count the number of hydrogens. And I see I got my C5H8 back here. This is also C5H8. I got my 8 hydrogens and 5 carbons. Here also I get my C5H8 back. Alright, so let's go get one and name them. Okay, let's take the same compound C5H8 we just worked with. Okay, and I'm just going to write one of them. So this is what one of our straight chain isomers look like. Right, this is what I had, right? And in this case it's quite simple. You get the longest chain, okay, and that happens to be the straight chain itself. So that's 5 carbons, right? And 5 carbon is pentane, but because we're dealing with a compound containing a triple bond, we replace the A and E with Y and E. So it'll be pentyne. That's your last name. And then you've got to go get the numbering done. So it'll be, you start from the left, because just like the double bond, the triple bond gets the preference. So it'll be 1, 2, 3, 4, and 5. And because the double bonds between 1 and 2, 1 gets the preference, the lowest of the two, so it'll be 1 pentyne. Alright, so I'm going to stop the video here, and I will give you some exercises in class that I want you to practice. Alright, so that concludes our discussion on alkanes, alkenes, and alkynes. The next time I'll see you, we will be talking about hybridization, which is an important concept, and how that contributes to molecules, shape, and stuff like that. Alright, stay tuned.